Morning, everyone. Do you think after Art's presentation there's anything left to be said? Or do you have any doubt that you should use global foundries with such strong partners? We have solved it for you. All you got to do is just put fingers to those keyboards, right? And there we go from there. Glad to be here. As you know, we had several announcements this morning in terms of press releases. One of them was the formation of a strategic business unit. So I'm very happy to be here standing in front of you as the Senior VP for the mobile and wireless infrastructure. And we'll weave that into the presentation as well as we go forward. So Tom had talked about the innovation equation and how we at Global Foundries weave into that to the fabric and fiber of what you do every day by creating the platforms. And how do you multiply yourself? You know, you always multiply yourself. You don't want to add one. When you multiply yourself through the application features, and then you literally elevate that through the IP that we provide to come up with these specialized application solutions. And then we'll hit on some of these during my conversation with you. My talk will be followed by Greg that will go deeper dive into technology features, and of course, then followed by Mike that will go into the IP and IP partnerships. So Tom talked about the over $65, $67 billion total foundry SAM, of which we have focused on $47 billion, which is your 12 nanometer and above. And basically by design, we have said there is about 25% of the market which chases the nodes, and that's not us. That's a choice. Now, on the other side is that what we're going to focus on. So we're going to focus on auto, industrial, and multi-market. We call that AIM. That's 24 billion of that $47 billion market. 24 billion. That's the largest one. And we're happy to announce today that Mike Hogan from Cyprus joined us as Senior VP driving that SBU. Next one is mobile and wireless infrastructure. That's 15 billion of that foundry SAM that we work on. And finally, computing and wired infrastructure is 8 billion. I think a lot of presentation that we heard from Art really elevated that in terms of the role of AI and intelligence, intelligent robots and intelligence within the big data, big compute, big everything. All large markets, all attractive markets. So let's go and look at what are the megatrends and opportunities that we have in our industry today. The things that I'm going to show you generally have got much great compounded annual growth rates than we hear cumulatively from the industry. Like we hear semiconductor industry is going to grow 6%, 7%, single digit, maybe get to the double digit in the outer years, or fluctuate. The kind of things we talk about, they're all double-digit growth markets. So there's ample opportunity to exceed and excel. Art took us about cavemen and walked us forward from there. I'll just take you about 15 years ago, 14 years ago. We had 3 megatrends at that time. First was the triple play, voice, data, video. That was a big thing. I remember the argument we had migrating from DOCSIS 2 to DOCSIS 3. Everything was about cable. We're here to obsolete that. Second one is when Wi-Fi became ubiquitous and when Intel Centrino launched, and that company tried to transform itself, or did transform itself from a CPU company to a communication company. Then we saw the evolution, very fast evolution of 802.11a, b, a, b, g, n, a, x, you name it, and then the beat goes on. Today, when you do an interview on campus, in the Maslow hierarchy of needs, used to be like food. Now if you ask the college students, Wi-Fi supersedes food. We live in a very connected world. And the third one, of course, was the introduction of 3G, 3.5G with high-speed uplinks and downlinks that changed our world. Now, fast forward about 15 years later, we are sitting literally at the edge of new things happening with Internet of Things, with cloud, in automotive, and in mobility. Now, last time when I talked to this crowd, and a lot of you were here before, I said one thing to remember. Think GF, think RF, think GF. Now, I'm going to move this exponential curve that we just heard from Art, exponential. So I'm going to ask you to remember 5 things by the time I leave this conversation. Okay, 5 things. So we'll go back to that. So let's look at the Internet of Things. We're looking at markets from intelligent wearables, let's call body because they provide feedback. Let's say your body temperature, your heart rate, various metabolics, into your system versus the old-fashioned, let's say, wearables where it was just like I'm going to listen to my music, that's my wearable. To your smart home, to your smart factories, to smart cities, and agriculture. Now I want to take one step back. What is common between all of these? And then that theme will repeat and repeat and repeat. All of them require low power. All of them require connectivity. Most of them, or almost all of them, require very efficient embedded memory. When we look at the body, there's a 1.2 billion unit moving at 16% CAGR. Home at 24% CAGR. Factory at 24% CAGR. Smart city and agriculture, 23% CAGR. Let me just hone in a little bit on the factory side for a second. Again, going back to Art, he talked about the evolution, or the revolution, various revolutions. We're at the 4th revolution in our factories. You know, we moved from steam to electricity, we moved then to CPUs and automation and robots. That was 3rd revolution. And the 4th revolution is based on artificial intelligence and machine learning, where machines talk to each other, learn from each other, where things become, instead of being reactive of today, become predictive, and then we can react to it properly. You augment that with virtual reality or augmented reality, then the machines teach us how to deal with the maintenance functions. The jet engine was a very good example, predicting the future through AI and machine learning. Robotics is becoming a very interesting field because we are becoming so attached, even as humans, to our robots that, you know, that vacuum cleaner to go around, a lot of people name them. Now there's a name for that, by the way. Mine is called Robbie the robot. And if at 6 a.m. it's not out there, I wonder what happened to Robbie. Robots and artificial intelligence have got now sensors where they're used, for example, in treatment, in autism, where a pet may be too dangerous. And then they can sense human feelings, they can respond to that. They're being used in elder care. So this whole field is building on intelligence, artificial intelligence around us that Art talked about. I'm going to dig deeper when I get to cloud. So we got intelligent wearables, intelligent homes, intelligent factories, intelligent cities. Just imagine the amount of NB-IoT that could be used in China alone, the smart cities that they're developing. So in body, you want to be connected at low power. At home, it's about safety, security, and energy. In factories, about manufacturing 4.0, the 4th revolution. And in cities, it's about the infrastructure build. Going back to Global Foundries platforms and the features that we add, you could see that we have got ultra-low power, ultra-low leakage, RF, embedded non-volatile memories through MRAMs, especially when you get to the more advanced nodes, like 22 nanometer. and embedded power management units. Within the home, with the low-power digital RF, with low-volt SRAMs and artificial intelligence and secure one-time programmable capabilities in factories with our RF power amplifiers, most efficient with millimeter wave connectivity, which gives you factory flexibility, and with our adaptive body biasing that I'll talk about, that even can predict the aging of your semiconductors. As was said in the previous talk, these systems last a long time. And finally, in your smart city and agriculture, dealing again, going back to ultra-low power, RF, adaptive body biasing, our embedded memories, our low-voltage SRAMs, and our secure OTPs. I'll go back. A common thread in a lot of things that we do is low power, efficient embedded memories, and RF or wireless connectivity. Let me give you an example in our 22FDX, and by the way, that's the power of our partnerships with Dolphin. With the ABB core, we can control and regulate the NWEL and PWEL voltages. That gives us unique capability to fine-tune our circuits or ICs for performance or for power. For performance or for power. Now, what I show here on the right side is a bar graph compared to no use of ABB. Let me take at half volt at 50 megahertz. Same at speed, you get 3x. Same power, you get 4x, everything else the same. Same everything in leakage, you get 7x PPA advantage. Oh, that's huge. In any wearable technology, that's huge. What's the barrier of entry to here? Availability of IP and circuit design expertise. Well, guys, if you're here, you're a bunch of intelligent IC designers, so that's no excuse. And the IP, as Mike will talk about it, will cover that. We cover you in terms of ability to do adaptive body bias. The second example, looking at the wearables and IoT, is having an efficient ultra-low power memory embedded. We are delivering that with MRAMs, with embedded MRAMs. Compared to flash, especially when you get to 22 nanometer or 12 nanometer FinFET or 22 nanometer FDX, we have shown the maturity of the technology through high yields. We have shown the endurance, matching industry standards. We have shown the reflow 5x, so you can rework the PC board, and also magnetic immunity, meeting all the standards. As one of the major European users of this technology commented, the digital MRAM chip is running on all cylinders. We're seeing some really nice power consumption figures. It's all about that. If you don't have a low power implementation in IoT, you don't have a product. So you combine that 22FDX as a platform, ABB, IP and a feature, and MRAM. You have a winning combination to enter your markets. Let me move to cloud megatrends. A lot of applications are moving to cloud. That means you have to develop efficient solutions in your silicon. Now, cloud service providers need to be able to differentiate themselves on architecture, on IP, and bring ability to be versatile through chiplets. Let me go back to something that Art said, power. In 2007, the data centers in the US consumed 3% of our power output. That's a lot. In 2020, that's predicted to be 7% of our power output. So every watt of power counts. And that brings you to a specialized approach. Let me leave you with that. Go to data center. Within the data center, you need extremely high-speed connectivity as the systems disaggregate to provide customized solution for the power and the speed of the accelerators. And another mode of connectivity, of course, within the cloud is for edge to edge is going to be 5G millimeter wave. Zero latency, 1 millisecond, close enough to zero, right? So when you put it together, you come up with a new world facing us. Robots that are intelligent, data centers that are not following your traditional CPU architectures. We'll talk about that later. And silicon photonics that connects within the data center everything. And 5G that connects everything in the factories. Or machine-to-machine linkage outside the factories, or machine-to-humans. So for that, in the AI, again, huge growth market, huge CAGR, data center the same thing, all double-digit, much bigger than your traditional semiconductor growth forecast. They need memory as accelerators. We develop memory as accelerators. We develop low-volt SRAM bits to put in conjunction with our co-locate with our core processors to enhance the speed of the accelerator. So let me go to the next one and say that the world started with microprocessors being the heart of everything. Then we said we need to accelerate them. Then we went to GPUs. Then from there we went to the FPGAs. The next step is domain-specific computing because we're going to move from CPU-centric to data-centric, to big data. And then within that is that you need to optimize every element and deliver performances that instead of being 10 to 50x improvement are 100 to 1,000x improvement in teraops and teraops per watt. Today we had an announcement on 12 LP Plus platform, plus the features that we have added in terms of low voltage SRAM, and MAC, multiply and accumulate, with custom SRAMs, with AI reference, and also 2.5D 3D packaging and interposers, giving vision inference a solution which is 2x more efficient than a simple node migration from 12 to 7 nanometer. Now that's the money that you can take to the bank. That is differentiation. That's out-of-the-box thinking. And we're very proud to announce that as something available to you. You can do what you think you have to do at 7, you can do it at 12 with Global Foundries. And we'll give you the tools and the capabilities. Now, within the data center, there is drivers and transmittance amplifiers that we serve with our platform in SiGe and RF CMOS. And on the other side, you need to be able to do laser integration that provide you from our 2.5 and 3D packaging and fiber attach capabilities, and then single chip photonic ICs. Platforms, applications, features leading to solutions that match the market segments you are in, the applications you're pursuing, the device groups and the devices that you produce. At the intersect of these two is our solution serving your device requirements. Automotive. The way I want to describe automotive is a data center on wheels, on 4 wheels, plus a smartphone. That's your automotive of the future. There's 19 billion ICs with a 14% CAGR. Electrification of the vehicles, which drives the power management and the battery management. The connectivity, which is required and delivered through autonomous capabilities, AI. And finally, those three combined change the equation, social equation that we are in, which is the shared mobility. If you look at the current next generation, maybe 2 generations from me. Most of them want to live in the cities. Most of them don't want to have car. Most of them are going to share resources. Are we going to have 100 million cars made, or are we going to have 40 million cars made? All of these have got socioeconomic effects. And for that, we offer, for example, in ADAS, we provide for driver safety, millimeter wave in terms of radars, embedded non-volatile memories, low-volt SRAMs, and LiDARs for pattern recognition. In electrification, high-voltage analog, and connectivity, going back to wireless integration. And in shared mobility, again, goes back, the first 3 of them give us the shared mobility outcome. Now, I wanted to kind of come a little bit down, further down to the ground from 100,000 feet, maybe to 10,000 feet. Here's a GF solutions in a real case in an automobile today. If you look at ADAS on the left side, and we are looking at short-range radar, complete solution with RF millimeter wave. This combines our 22 FDX with the millimeter wave function features. If you look at ADAS for imaging device, that's the low noise and ultra low power devices that we have. Greg will dig deeper in terms of what these features are on top of our platforms. I'm going to use just a couple of examples. You go to powertrain, that's our high voltage analog. You go to another one, let's go to long range radar. That's our RF millimeter wave enabled by SIGI technologies. So with Auto Pro, we provide auto-grade solutions to your device requirements in auto. An example of a foundry reference design that we do, we have a design team, over 150 or so people, that take these technologies, take the standards, and translate that to workable devices that you can have a starting point 6 or 9 months ahead of the time versus here's a PDK, go figure out radar. I invite you to work with us. We did an announcement today on the 22 FDX and the millimeter wave radar solutions. So if you're in automotive, radar, come see us. Finally, the last one is mobility. My favorite one. Everything gonna have a radio in it. And at 5G, we have got 2 flavors. We have the sub-6 gigahertz, which uses massive MIMO technologies. The bandwidth are now 100 megahertz. And then you have got millimeter wave that goes above 10. US Verizon is sitting at 28. 24 in Europe, gigahertz. You've got 39 coming in, spectrums available to people. AT&T is leading the charge. T-Mobile is leading the charge. Everybody's coming with a flavor of it, whether it's in the low band, mid band, or high band. High band referring to the millimeter wave, low bands referring to the sub-6. And with the 5G mobility, your handsets, roughly about billion devices in the 2022-2023 timeframe. The wireless charging for convenience, NFC for security, and of course, displays. You need ultra-low power solutions for the displays. With that, again, we map our capabilities in terms of here's the platform, here is the features, here's the solution. For RF millimeter wave, we have 2 major solutions for RF millimeter waves, 22 FDX and 45 RF-SOI. Today, we also made an announcement that 45 RF-SOI reached a billion design win target. When you look at wireless charging, these are specific LDMOS, high voltage, and when you look to NFC, it is embedded memories, embedded flash, EMRAMs, but of course in display we go to high voltage and high HD SRAMs. Now, 4G is not just the evolution to 5G. 5G is a massive transformation. It's converging telco, internet, and cloud companies. It's taking computing from a central function to edge compute and allows you to have edge-to-edge, vehicle-to-vehicle connectivity. at less than 1 millisecond latency. It's real-time inference for massive connectivity and low latency. We're talking about 20 gigabits per second of downlink. We're talking about 10 gigabits per second uplink with 1 millisecond latency. It is not an extension of 4.2. It's a revolution in what we can do and impacts what we do with AI, what we do at EdgeSense, what we do in our social fabric. It's the first time that also devices, handsets, are coming with 5G capabilities before the network is there, which means the application engineers can write all that software that Art was talking about ahead of the full network deployment, which means acceleration of deployment. So things are exponentially moving up. So we're moving from your mobile IoT to the 5G, mobile IoT, AI compute, and enormous amount of connected devices per person from a couple to 15, 20 and above. A trillion intelligent devices connected through 5G networks by 2035. Now that's transformation. We can look at a handset. There's radio part. We provide solutions through our RF, millimeter wave, and advanced packaging. But it's not just that. It is in the ISPs. It is in the power management. It's in the audio amplifiers. It's in our wireless charging. It is our haptics. It is our security, display driver, envelope tracker. Focused approach to market, mobility and wireless infrastructure, mobility. And you can see the same thing in the infrastructure. So as my time comes to a close, I want you to remember 5 things now. Remember exponential, 5 things. First thing was, of course, think RF, think GF. Never forget that one. Think 5G, think GF, because 5G is beyond RF. It's all the AI that goes in there. When you think automotive, think GF and Auto Pro and all the solutions that we showed you. And when you think IoT, think 22FDX. And above all, when you think about AI, think 12LP+, our announcement today. Thank you very much.